Okay, so far we have had motion problems where distance 1 was equal to distance 2. So those were problems where somebody started at a certain point, traveled to a certain point, another person started at a certain point, traveled to this same point or same distance, so that distance 1 was equal to distance 2. It could look like this, or it could have been traveled out this way at a certain rate and then traveled back maybe at a different rate. But in this case also, this distance was still equal to this. How far they traveled was still the same. Now we're going to look at some problems where distance 1 is not equal to distance 2, but there's a different type of relation involved. We're going to look at some problems where we're given what this total distance is, but one person might start at a certain point, one person travels west and another person travels east, or it could be north and south. But the fact that this distance 1 plus distance 2 is equal to some number, and we'll just call it k for now. Okay, so distance 1 plus distance 2 is equal to some number, and they'll give you what this number is, what this distance plus this distance is equal to. It could look like that, or it could look like something like this, where one person starts here, starts traveling in this direction, another person starts here, starts traveling in this direction, but you can see with this as well that distance 1 plus distance 2 is still going to be equal to this total distance that, again, we'll call k. Okay? 2 examples, or it could also be something like this, where somebody starts off walking for a certain amount of time and then runs the rest of it. But the rate here would be different from the rate here, because the rate walking should be different from the rate running. But again, you can see that that first distance plus the second distance is going to be equal to some number that they will give you. Okay? So these are kind of the next scenarios that you might see, where you're going to take distance 1 plus distance 2 and set it equal to a number. Same thing here, but you can see how the setup's different, or the way the question we worded is a little different, but it means the same thing. You're just adding distance 1 plus distance 2, it equals some number. Same thing here. Okay? So let's listen to some problems and see how those are solved. And again, with that, and I'm gonna right up here, how far down can I go? All right. Distance 1 plus distance 2 is equal to k. Remembering the fact that distance is equal to rate times time, I can rewrite d as this. So I'm going to rewrite distance 1 as rate times time. Distance 2 I'm rewriting as rate times time is equal to k. All right. So we have a southbound bus left Fort Walton Beach at 9 a.m. 2 hours later, a northbound bus left the same station. So they're starting in the same place and going in opposite directions. If the buses traveled at the same rate, so we know that the R's are going to be equal to each other, and were 352 kilometers apart at 2 p.m., find the rate of the buses. All right. So, a southbound bus left Fort Walton Beach at 9 a.m. And I know that they're traveling in different directions, so I'm going to do this and this, okay? This is Fort Walton, and we'll say this is southbound, okay? So this is heading south, this is going to be heading north. Okay, this one left at 9 a.m. 2 hours later, so this one's leaving at 11 a.m. Left the same station if the bus has traveled at the same rate. So the rate, we can just say rate 1 is equal to rate 2, or we can just simply call it rate. We don't even need this R1 and R2 in here because they're going the same speed. They were 352 kilometers apart. Okay, here we go. This is our K. 352 miles apart at 2 p.m. All right, so from this information, we can figure out what these times are. So the time 1 by the southbound bus is going to be, he started at 9 a.m. and then at 2 p.m. was when we're stopping the time. This is when they're 352 miles apart. So 9 a.m. to 2 p.m. So we know that time 1 is equal to 5 hours. Okay. Time 2 is going to be equal to, well, 11 a.m. to 2 p.m. is going to be 3 hours. All right, now we have all of the information that we need for this because these R's are equal to each other. The fact is we're only going to have one variable left when we fill in all of our information. So we're going to have R times time 1 plus R times time 2, and we know that's equal to 352. Here we have like terms, so we can simply add them. 5R plus 3R is 8R. 8R is equal to 352. Again, because these are being multiplied, to undo, we're going to divide. So R is equal to, let's see, 8 goes into 35 4 times. That would be 32. So there would be 3 left over. 8 goes into 32, 44. So the rate was 44 kilometers per hour. And that's what they were asking for, the rate of the buses. So that's the first one.